Black math! Give me some math and I'll give you some flack. Black math!
Okay, we are doing lesson 47. We're going to talk about circles and inscribed angles. Okay. Scribe. Remember what scribe means in geometry? Scribed. What do you think of when you think of scribe? Right. Okay. So in geometry that means drawn. Okay. So inscribed angles are angles drawn inside of something, and we're going to talk about angles being drawn inside of circles. Okay. All right. So lessons 23 and 26 introduce circles. Not that you didn't know what circles were, but
It's my desk.
we talked about just angles inside of circles. We talked about central angles. Central angles in a circle are where the vertex of the angle is on the center of the circle. Okay, so the measure of that angle is pretty easy because you can just look at the measure of the arc or vice versa. Okay, so an inscribed angle is an angle where the vertex is on the circle. Okay, so this is an inscribed angle. I'm just writing it right in. Okay, so this is where the vertex is on the circle. Okay, and so this guy here, this arc is called the intercepted arc. Intercepted is what's like intersection and interception mean kind of the same thing in geometry. It's what arc intersects that angle. Okay, this is what's touching that angle. Intercepted arc. Now, here's the deal. This is always going to be twice the measure of the inscribed angle. So for example, if this was 30 degrees, this is going to be 60 degrees. Okay, it's different than a central angle. A central angle, if you were to put the vertex right there and intercept that same arc, see how that angle is a little bigger. That angle is a little bigger, and it makes sense because you're going twice as far, so that means the angle is going to be twice as small because it doesn't have to spread open as much to reach that. Okay. So that's an easy one to remember because you can kind of look at it and use your gut as well. If this is 60 degrees, okay. If this was 30 degrees, well, if I put 6 of those around there, that wouldn't equal 360. Okay? So use your gut as well. So that's theorem 47.1 is basically that math. The measure of an inscribed angle is equal to half the measure of its intercepted arc, which is basically, so if the measure of the arc is twice the angle, that means the angle is half the arc, right? If I'm twice your age, which I'm more than twice your age, but if I'm twice your age, that means you're half my age. So it means the same thing. So theorem 47.1 says the measure of an inscribed angle is equal to half the measure of its intercepted arc. Okay. I don't know what distinguishes what they call a theorem and what they call a corollary, but this seems like more of a corollary to me to theorem 47.1. But this is what theorem 47.2 says. If an inscribed angle intercepts a semicircle, then it's a right angle. Okay, so for example, if here's my intercepted
Wait, what did theorem 47.2 say?
so if this is my angle, so if an inscribed angle intercepts a semicircle, then it is a right angle. Now here's why. Okay, if an inscribed, let's just write it out first. If an inscribed angle intercepts a semicircle, how many degrees is a semicircle?
180.
180, and what's 1/2 of 180?
90.
So that's why this seems more of like a corollary. It's the same thing, it's just with a specific angle. So if an inscribed angle intercepts a semicircle, which is just a 180-degree arc, then that angle, that inscribed angle is a right angle. Then it is a right angle. Okay, so it kind of makes sense. If this is a 180, this is an arc, then this inscribed angle, remember, is half the measure of its intercepted arc. So if the intercepted arc is 180, half of the circle, then that's going to be 90 degrees. Okay. So I'll let you write that down. Okay, so let's look at this example here. You guys see this? So here is example 1. So let's look at this diagram real quick. So let's see if we can figure out all the angles. Or not, maybe not all. Well, we can figure out all of the angles. Okay, so this is what we got. Let's see here. I guess I could write on there. Should I write on there?
What?
Oh,
Do
it's
it.
too confusing.
It's
Too confusing. Let's just redraw it, whatever. So it looks like this. 52 degrees.
No.
Okay, what angle do you want to start with?
JL would be also 52.
JLK.
Okay, so this is 52-degree arc. Yep.
JML. JML.
All right, so JML is already given to us.
Just
It's
saying.
52 degrees.
Oh, I thought that was, never mind. I was like,
What?
anyways, what about like that LK? The arc of LK.
Okay, so
J.
first, to determine the arc of LK, we have to figure out what that angle is that intercepts that arc. What angle?
So it would be half
LMK?
of 52.
LMK.
Yeah, what's LMK? What's this?
It's probably 52 minus 180.
Yep, 180 minus 52 is, what is it, 128?
Yeah.
Okay. All right, what else?
Wouldn't the angle of K be half of 52?
Yes, that's right. Do you guys hear that? So this angle K, this is an inscribed angle, so that means this measure is going to be half of its intercepted arc, which is 52. So this is going to be 26. All right, good.
Then it has to equal 180.
And then this all has to equal 180. So 128 plus 26 is 154. So this is going to be, what is that? 26 degrees. Okay. What about this arc here?
Oh.
What's the measure of LK?
You have to use the angle of M, right?
There's a lot of angle M's.
57.
So it's not 57. How'd you get 57?
I just guessed.
What's the measure of arc LK or KL? Do you know, Hallie?
Would it be 26 plus the other 26?
So you're making it overcomplicated because it gives you the central angle. The central angle right here intercepts this arc. This 128 is the central angle. So what's this arc? 128. Remember, the central angle is the same as the arc that intercepts. All right, so that means this is going to be, let's see, that's 180. So that makes sense because that kind of looks like a diameter. That looks like a semicircle. So then this is going to be 180 as well. Okay, so a lot of these problems you're going to be subtracting from 180 and 360 and dividing by 2 or multiplying by 2, depending on which direction you're going. Okay, so the questions say name the inscribed angle. Okay, that's just JKL. Or LKJ, or you could just say angle K because there's only one angle connected to K. Name the arc intercepted, so arc JL. If JML equals 52, find JKL. So that's half of that, which is 26. We did that. And then prove it. This proves it. If you want to look at that, you can. Okay. Look at example 2. Find these measures. So the only thing it gives us are these right here. So see if you can find on your own angles 1, 2, and 3. I'm gonna get really cool. What the? Sorry, I'm changing things up. You see it okay?
Do we know it's a semicircle? Or is that not given?
I can't our test be cahoots.
Yes, it is. So this is circle O, so that is a semicircle. So if it says circle O, that means O is the center. And if that line goes through the center, then it's a semicircle. Good question. I'm gonna mess you up again, 1 second. Okay. There he is. All right, what'd you guys get?
Give me a second, and I almost got it. I'm very close.
I'm just gonna redraw it up here for now.
Okay.
So drawn a little bit different, but 1, 2, 3, and this is 70. Was it 76? Okay. So Tobin's got it. Anyone else?
Isn't that supposed to be an O, not a
Yeah,
C?
that's supposed to be
Oh.
Huh.
I thought it was a 6 at first, but then it wasn't. Oh my gosh, that is also a good job.
Angle circle would be half of 170, but it's a semicircle. The other one, arc. But 1 and 3, so half that and it became 1. And 1. Did I say 170?
No.
It's 76, right?
Yeah, I meant 76.
It's pretty much a guarantee.
Half
If
of
it's-
76, because it's.
So 3 is half of 76. Semicircle, so we can find out the other side. And 1 is then half of that other side.
So it's half of 180.
There's Tom.
What?
I'm sorry.
You already have a 90 degree angle.
I'm not a
Some
good.
reasons.
What problem is it?
What? I think it's an example.
Oh,
Okay, it's really slow, but all right, this is gonna be cool. You just bear with me.
Shrek. I love Shrek. Shrek's so good.
I watched Shrek the Third yesterday.
Oh my gosh, I haven't seen that one in so long. I love Shrek. Puss in Boots is so good. Yeah, I love Puss in Boots. So good.
I like this one. No, I do like it.
Yeah,
I like
there's I started.
With the mom just like,
What about the Shrek in the second Shrek? When he's holding out for hero.
I like in the second track when they go to the
I'm sorry.
I also like when she sings the song to that side, and I like it when
That's a holding out for hero.
and accidentally in love by
Nothing will beat the first Shrek though in my mind. Shrek is always my Shrek.
Dude,
Like,
nobody
come on,
wants
when
you
he
to.
like comes
Get
out
out.
with all Shrek playing, iconic. But like,
For some reason, this is extremely slow, but let's just forget it.
that. That was a great day, math. I feel like we really learned a lot.
fine. You're gonna be that slow? All right, so
Let's just call it a day. Rage quit in anger.
yeah, we could.
We should. I feel like we've learned a lot.
All right, so what do you got? So somebody besides Tobin, who can give me the measure to angle 3?
Isn't it just half of like 73 or whatever?
Of 76?
Yeah.
Yep. So 3. Hey, it's working, kind of. So this is just 76 divided by 2.
Which is 35 plus 3 so 38. Not 3.
Okay. All right. What about angle 2?
Can I answer this one?
Sure.
It's angle 2, I got 92.
Shouldn't be 92. What about what's angle 2?
Not 92.
Not 92. What is it?
90.
90. Right. Why?
Because you know it. Semicircle.
Yeah, it goes to it intersects the semicircle. Good job. So remember, a semicircle is 180 degrees, so half of that is 90. All right, so now you can figure out angle 1, right? How do you figure out angle 1?
Oh.
What is it?
You add 80 and 38, right?
90 and 38, and
90
you get
and
128.
Yes.
And then what?
And then you minus that by 180. And so it should be
142.
yeah.
Not 140, just 42.
Yeah.
Or 52, whatever.
Oh, what was the number?
So let's just make sure it adds up. 52 plus 38 is 90, plus another 90 is 180. Okay. Sweet. All right, moving on.
We did really good today.
Here's 3740, theorem 4730. Theorem 47.3.
We do.
Your camera makes your shirt look like royal blue.
Isn't that royal blue?
Actually,
more
that's like a faded
It's a
thin.
slate.
No, it's not sky. Sky's a lot
I learned
lighter.
it's slate, right? This is what you call this kind of shirt?
Yeah,
It's
it's like
slate.
a gray, blue mixed
That's
together.
like
It's
a
slate.
grayish hint to
That's
it.
sapphire. That's like
No,
gold.
that's like royal blue.
That's
Sapphire's a little lighter and royal's a little darker. So that's
Yeah.
like royal blue.
one time I had this
47.3.
here and it was that color.
If two inscribed angles
Yeah,
intercept the
scrunchy
same
that
arc,
color.
they are congruent.
I'm scrunchy like that. Not in my head.
If two inscribed angles intercept the same arc,
Can we still on this?
then what? Well, let's just draw an example. Let's say I have, here's a circle, and the blue angle intercepts this arc right here. Okay? That's the arc that blue angle intercepts. Let's draw another angle right here. So see how the green and the blue angles intercept the same arc. So what can we say about these angle measurements? They're the same, they're congruent. Then the angles are congruent. Which makes sense, just do the math. Whatever this is, divided by 2. Whatever this is, divided by 2. Oh, I just did that, so I'm gonna get the same answer. Okay, good. So let's do another one. Let's keep going here. Okay, look at this guy. Let's see if we can, what is it asking us to do? We're going to find the measures of FGH and GH. So FGH, we want to find the measure of this thing, this arc, and then the measure of this arc. Okay, can we do that? So what do you know so far? What's that?
Are those the only two objectives?
Yep. So what do we know so far?
We know.
Can someone tell me some arc measures or angle measures or whatever?
G would be
The
half.
measure.
So what's the measure of G?
It would be half 36.
Yep, so that's 18 degrees, right? Good. What else? We're asked to find arcs, not really angles, but that's okay.
We know the entire thing is 360, so if we take 36 away from 360.
Okay, so yeah, so that angle measure, yeah. I think we are asked to find that angle. We did, 18 degrees. But yeah, so 36 minus 360 minus 36 is going to be 324. Okay. All right. What about the arc G to H?
It would be double 48.
That would be GJ.
Or wait, what is
That would be
48?
GJ. That's right. So this would be 96 degrees. Good job.
And then plus 48 would get it. Wait, what arc are we trying to find? G8?
We're trying to find G to H, GH. So we
Then
need to
would be-
figure out what HJ is. How do we do that?
Wouldn't that be 48? Wait, no.
So the only angles I see are this 48-degree angle, so that's a 96-degree arc, and then this 18-degree angle, which is 36-degree arc. Okay. And then, actually, let me just look here. This might be. Oh, we are trying to find GJ.
Okay.
Sorry. All right, so we're good. Good job. Okay, here is, here's a good one. Let's do this. Let's do this. Let's do this. So let's find the angles Y and A, okay? So what do you know about these two angles, Y and A?
Shouldn't they be equal?
Yep. Do you see why those are equal, guys? Why Y and A are equal? Because they intercept the same arc. Right? So if they intercept the same arc, then we can set these equal to each other. So we can say 2C plus 9 equals 3C.
Which would be 9.
Okay? So basically,
And
solve that. So C equals 9. So what's the measure of the angle?
would it not be 9?
Nope. What's the measure of
Oh.
angle Y and angle A?
You plug 9 back.
Right. So 2C, so 2 times 9 is 18 plus 9 is 27 degrees.
And then
3
Also
times 9,
27.
and just check to make sure it's the same thing. It should be the same thing, and it is. So there you go. Okay, another theorem. Why don't you write this down? Theorem 47.4.
Wait, why were there was 47 I'm just kidding. I see it. I must have missed it. That's my idea.
Can you see that, or do I need to?
Yeah. 1 second.
Wait,
So-
I can't see that at all. I'm so sorry.
Okay, that's all right. I'll write it out.
Wait, what's that theorem? If two intercepted equals to intercepted.
So theorem 47.4 has to deal with quadrilaterals. So how many inscribed angles are in an inscribed quadrilateral? Yep. If a quadrilateral is inscribed in a circle, then let's see if we can figure out what the then is going to be. So here is a quadrilateral, just a random. So here's a random quadrilateral, okay? So look at this angle.
Do you find any chance?
Is it gonna say something 360?
Maybe. So look at these opposite angles. What can we say about the opposite angles of a quadrilateral? Look at the green one. See how the green one? Let's look at the arc it intercepts.
They're congruent.
They're not congruent.
They equal 360, right?
So the arcs equal 360, right? Because look at this blue arc here. See the blue angle intercepts this arc, and the green angle intercepts the rest of the circle. So the arcs add up to 360. So what are the angles going to add up to? How do you determine the measure of the angle of an inscribed angle?
The whole thing?
You cut the arc in half, right? So if the arcs add up to 1 to 360, what are the angles going to add up to? What?
90.
Close, 180. Then opposite angles are supplementary. They add up to 180. Makes sense because half of 360 is 180. Okay, so far so good. So if you had something like this, 4z degrees, and then this is 3z plus 5. How do you figure out what those angles are? How do you figure out what z is? Somebody else besides Tobin. Thanks for participating, but let's just get more people
What's the question?
involved. How do you solve for z?
Which one's
It says 4z over here, and then it has 3z plus 5 over there.
They're opposite of each other.
Yep.
So basically, can't you, because they like fit all around 180,
Yep.
can you just subtract whatever the number is from 180? I just can't read what the number is.
Well, they're not numbers. This is 4z, and this is 3z plus 5. You could subtract one of those from 180, or the easier thing to do is just add them together to equal 180.
Okay.
So we're going to do this equation. We're going to say 4z plus 3z plus 5 has to equal 180, right? According to theorem 47.4, the opposite angles in that quadrilateral have to add up to 180, right? So let's do that. Combine like terms. 7z plus 5 equals 180. Subtract 5 from both sides. 7z equals 175. Divide by 7, and you get 25. So z equals 25. So what's the measure of the angle?
equals 25, so you just do, what is it, z plus 4 or something?
Okay, so z times 4, so that means that angle is going to be 100 degrees, right? Because
Yeah,
of z
and
equals
then
25.
The other one's 80 then.
So that has to be 80, but let's just make sure it makes sense. 3 times 25 is 75, plus 5 more is 80. Boom. Okay,
Sorry.
good. All right, moving on. Let's move on to lesson. Moving on to lesson 48. Okay, lesson 48, we're going to talk about indirect proofs. This is annoying. Sorry. So here's what we're going to do. We're just going to kind of walk through it. We're not going to spend a lot of time with indirect proof, but this reminds me of like a really passive aggressive person. Just say what you want to say.
I just said
Don't beat around the bush. This is an indirect proof. So this is a little uncomfortable, but let me talk to you about it. So direct reasoning is what we're used to. Direct reasoning is the process of reasoning that begins with a true hypothesis, like an if statement, all right, and builds a logical argument to show that the conclusion is true, right? We all know that. In some cases, it's not possible to prove a statement directly. Okay, so an indirect proof must be used. An indirect proof is a proof in which the statement to be proved is assumed to be false. Well, let's say that it isn't true. Okay, assumed to be false, okay, and a contradiction is shown. So if you assume that it's false, and then, well, here's what happens if it's false. It doesn't work. So it must be true, okay? It seems a little deceptive, doesn't it? Well, let's just say you're wrong. Well, then that would mean this would be wrong. So therefore, it must be true. So people really abuse this indirect proof. They abuse that when they try to prove their point and things like that. So be careful when using or reading an indirect proof. This is also called proof by contradiction. Okay? So here's what theorem 4.1 says. If two lines intersect, then they intersect at exactly 1 point. Okay? So let's write that down. Two lines, theorem 4.1. If two lines intersect, so if they're not parallel, then they intersect at exactly 1 point. Okay? If two lines intersect, then they intersect at exactly 1 point. All right. So we're going to prove that this is true using an indirect proof. Since this is an indirect proof, we start by assuming that the statement is not true. In other words, it must be possible for two lines to intersect at more than 1 point, for it to come back around and intersect again. So we assume, step one, we assume the conclusion is false. Okay? So we're going to say, assume that lines M and N, so in this case, we're going to assume lines M and N intersect at both points. At both points A and B. Okay? All right, now step 2. We have to show that our assumption is contradicted. By a theorem or postulate or something. Contradicted by theorem, postulate, etc. Okay? So here's what we say. Now that we must show that this contradicts another theorem or postulate. It contradicts postulate 5. So this contradicts postulate 5. Here's what postulate 5 says. Through any 2 points, there exists exactly one line. Through any 2 points, there exists exactly one line. But we're saying that through any 2 points, lines M and N go through both of those points. Okay, so since it is not possible for 2 lines to pass through both points A and B, according to postulate 5, the assumption we have made is contradicted and theorem 4.1 must be correct. So that's step 3, is state assumption must be false. So contradiction, so the conclusion must be true. Okay, I'm gonna get a new marker here. See how this is just kind of like, wait a minute, doesn't this seem like 2 wrongs make a right type of thing?
No,
It almost feels like that.
8 wrongs make a right.
8 wrongs?
2 wrongs don't make a right,
Cat.
but 3 lefts make a right. You guys know that?
And it's true.
This is a weird one. Okay. You can also try to draw a diagram, which it's hard to draw a diagram with 2 lines going through 2 points because it's impossible. But sometimes that will help you form your words and form your argument if you do that. Okay. So here is, let's do another one. Do you guys get these steps down? These are good steps. You can also find them in lesson 48. It lists the steps for you. So there's just 3 steps. Assume conclusion is false. Show that the assumption is contradicted by another theorem or postulate or something. And then state the assumption must be false, so the conclusion must be true. Okay? All right, so we're going to use this diagram to do another indirect proof. This marker isn't great. Use the diagram to prove 47.2. So theorem 47.2 says if an inscribed angle intercepts a semicircle, then it's a right angle. Theorem 47.2, we're going to prove this is correct using an indirect proof. If 2 inscribed angles intercept, if an inscribed angle intercepts, a semicircle, then it is a right angle, 90 degrees. Okay, this one will be pretty easy because we can just use 47.1 to contradict that. Okay, so we can say, let's assume the measure of the angle of angle B does not equal 90. So we're going to prove that it's false. So we're going to assume the measure of angle B does not equal 90. Do you see what we did? We just said the conclusion. We're assuming the conclusion is false. All right. But theorem 47.1 says that the measure of an inscribed angle is half its intercepted arc. Right? Well, the intercepted arc is 180 degrees. Half of 180 is 90. So therefore, QED, little triangle dot, assumption is false. And conclusion is true. And then state the conclusion. Angle B, measure of angle B equals 90 degrees. See how this is just, proofs by themselves are a little bit concerning and hard to get your head around. Indirect proofs are just a whole lot of confusion to a lot of people. Yes.
Will this be on the test?
I can't remember if something like this will be on the test. If it is, but we're going to go over the test very carefully.
If it is, can we just write theorem number contradicts this?
Yeah.
Assumption?
Yeah.
That's all we need.
Yeah. Okay. So the last example is just writing an indirect proof. I don't think we need to do any more. I think we'll call it at that. Good job. Have a great weekend.